Welcome back. Here is what we predicted. I was like, wait, what am I doing? Here's what we predicted. Well, first of all, let's start with energy total equals energy total at the beginning, because the law of conservation of mass is a thing.
It's a thing.
And we can break this up into, we're talking about mechanical conservation of energy, so kinetic energy plus UG equals the kinetic energy at the end plus UG at the end. And at the very beginning, it's not moving, right?
Well, no, it is moving.
Oh, sorry. At the very beginning, we push the button, right?
But the key is, where do you want gravitational potential energy to be zero?
I want it to be zero at the bottom.
I like that.
Yeah, that makes our life easy. Good question. And then at the top,
It comes to a stop.
it stops. So that's where our kinetic energy is zero. And we get to pick where we want our UG to be zero. So essentially, we have this.
So, and we know how much kinetic energy it is. It's how much?
From our notes, we had that kinetic energy equals 0.995 joules.
Was it 0.9905 or 0.09?
I think it was I think it might have been 0.0. Oh, 0.
Just move the decimal over. No harm,
Okay.
no foul.
Okay, so
That's how much gravitational potential energy it's going to have.
we're going to plug this in a second. First, let's keep going here. What's my equation to find UG?
Miller genuine, no, MGH.
I was going to go with it. MGH. And what are we trying to find here again?
How far up the ramp is going to go, but if we can find how high above its starting point, we can use a trigonometry method.
Okay, so we should find this one. So can I divide by mg? Divide by mg. H is going to equal kinetic energy. Let me just go ahead and plug these in. Kinetic energy divided by mg. Kinetic energy was 0.0995 joules divided by...
The mass of the card is 0.250 kilograms. I'm going to go grab your calculator.
Excellent choice. Times
10.
gravity. And no negative because we're working up, moving up against the force of gravity. 0.0995 divided by, I'm going to put the bottom in parentheses, 250 times 10, right?
Yeah.
And I get 0.00398.
So that's 0.04 meters, which is 4 centimeters.
Oh, for perspective here. Okay, 4 centimeters.
So now what are we going to do with that?
Okay, well, let's draw a quick diagram. So that just tells me...
That's the height, right?
Yeah, so we know that this angle is 5 degrees, and we just measured the height.
Yeah, we just calculated the height.
Oh, sorry, yeah, I calculated that. Height. Is there some way that we could figure out?
Well, the height is going to be what part of the triangle?
The height is going to be the opposite.
Yeah, SOHCAHTOA.
Hypotenuse. The sine of 5 degrees is going to equal
The opposite over the hypotenuse, right?
over the hypotenuse. I'm just going to switch these.
Because we want the hypotenuse, yeah?
Yeah, we want to know how far it's going to go up the ramp. What was my opposite? It was, we're going to call it 0.04 meters divided by, oh yeah, and I put this down here, right? The sine of 5. Okay. So 0.04 divided by the sine of 5, and I get 0.4, we'll call it 0.46. 0.46 meters, so almost half a meter, almost.
Yeah.
Okay, so shall we see how we do?
Okay, so you go around on the other side so I can get this.
Now, let's zoom in here where it should
So
be.
first of all, we're starting, let's do the front. That's
Okay.
about 20.5 centimeters.
So 20 and a half
20
plus
and a half
46.
plus 46 should be 60 something. It should be up right about here. I don't think it's going to go that far.
All right, here we go.
Where's it go? Oh, it went
Right
to
there?
60.
Woohoo! And we said 64, right?
Yeah.
So why didn't it go all the way up? Friction,
Friction.
right? It's not a perfect system here. It's not a frictionless, no, perfect,
So-
not real, right? But
Our prediction was pretty close. Was yours?
okay. What do we have another question?
Well, no, you know, that was that. Go
Oh.
back to that last one.
Predict, please. If the cart were to be shot up at a steeper up a steeper ramp, describe how its motion will change.
Well, that means
Describe.
if you take the track and do like this.
What would happen? One.
Don't show him, don't show him.
Not yet. What would happen? Now think about. Well, let me actually go to my next slide here, right? Because then we have something about the law.
Yeah.
Okay. Reminder. So what will happen when the ramp is steeper? Describe how its motion will change. It will change. How? Little reminder. Energy cannot be created or destroyed. Only change from one form to another.
Oh, yeah.
Okay, and I forget what's on the next one here. Mechanical energy, the form of energy due to the position, potential, or the movement of mass. Kinetic energy.
These
So,
are just reminders of what we've been dealing with.
so we've been talking about kinetic energy, potential energy. They added together, they both have to equal the sum of whatever they're supposed to
Yep.
be. You can't lose energy. Gravitational potential energy. Due to elevation above a reference point, we can use this equation. Work is equal to mg delta h, and that gives me my
Ugh. Sweet.
Ugh.
This is just reminding what we're dealing
Just
with.
reminding. Okay, so keep in mind, you should be able to. Should we talk about the answer to that, or
Answer to what?
answer to how the motion
You
should
can do
change?
that in class.
All right, ladies and gentlemen, be ready for it. Homework, AP book 167, numbers 36 through 38. This time you are really doing these ones. Last time I messed up. You're doing these ones tonight. Go get them.